Well, welcome everybody to the Wargaming the Future panel, specifically talking about artificial intelligence, machine learning, and how we're going to represent those in wargaming. We have a number of different topic areas, attack axes, looking at that question. Today we have Matt Santaspirit from Army DevCom rep down at the Mad Scientist group at TRADOC. And we have Justin Peachy, who's Dr. Peachy. He's at the Center for Naval Analysis. And then we have myself, Paul Works, and I'm from the Research and Analysis Center. And to start us off this morning, we'll have Matt.
Okay, thanks, Paul. So as Paul said, I'm Matt Santaspirit. So I work for the DevCom Armament Center. We are up in Picatinny Arsenal, New Jersey. Essentially, we do all the R&D for anything that blows up that the Army uses, more or less. For the past 5 years, I have been down at Fort Eustis, Virginia, working on site in the Intel team there as the Armament Center rep down there and part of the Mad Scientist team. I'll give just a quick overview of what Mad Scientist does and kind of how it relates to what we're doing here. So Mad Scientist is a U.S. Army initiative, and we continually look at the future of warfare. We challenge the Army's assumptions, and we try to do external outreach with academia, industry, and other parts of government. So we've looked at virtual and distributed wargaming and how emerging technologies like artificial intelligence and machine learning are going to enable those virtual and distributed wargaming processes. So let's jump into the next slide. What I plan to do here is just kind of give some general overviews, a look at some of the net positives of virtual and distributed wargaming, some things that we've done in the past year, and then how AI and ML kind of plays into that and enables that. So I'm not going to get too technical. I do have an undergraduate degree in science, but regrettably it's political science, so I don't think I'm going to be very useful in that realm. But I can sort of look at the implications that are maybe in the next 10 to 20 years, if we start incorporating these things in, that's kind of how it'll help us. So I'm going to look at it from an Army-centric perspective, just because that's my point of view. But really, you could apply this, to any field. So in general, looking at what we've got on the slide here, some of the net positives of doing these virtual war games is that you can bring people in from all over the world, and you don't have to worry about travel. You don't have to worry about, do we have enough room in this building? Do we have enough, seats here? Do we have enough money to fund all this? You can get that broad participation. And with the way that, in the past year, we've seen that, doing things over live streams is incredibly effective and actually a lot easier than probably I think a lot of people thought before this pandemic hit. The other side of virtual wargaming is you can do many, many more iterations of this. So sometimes when you do like an in-person tabletop war game, or even ones that's distributed by groups, those take days and days and days to run through all the steps, run through all the turns, and then analyze after the fact. If you're doing this on something that is more computer based, you can do those iterations. You can get one exercise out and then make minor tweaks to it and iterate and see what the differences are and collect data from that. You can also reset very quickly, which allows you to get more reps of the individual who's participating in it, whether it's for training or whether it's for exploration purposes. You can do that so quickly, and that helps your mental reps. It helps you learn faster. It also has more, virtual wargaming allows for more agility, so you can make quick changes to things that otherwise wouldn't be possible when you've been planning and preparing for something that's in person for months and months and months, and you work out all the rules and everybody's read them and gone through them. It's hard to make one of those changes and have the system understand that change has been made. But when you have it in a virtual setting, you can tweak the settings to it, and those things happen much more quickly. So how is artificial intelligence and machine learning going to play into this? So obviously the lifeblood of artificial intelligence, machine learning, anything like that is going to be data. And for the Army, we have a huge opportunity here because we have a plethora of data that we can pull from. We've got the National Training Center, we've got the Joint Readiness Training Center, where they're going through all these training exercises, and we can pull that data in well, we have the opportunity, I should say, to pull that data in and use that in the war games. We have real world exercise data that we can pull in. What we need artificial intelligence to kind of do for us, though, is determine, one, is this data that we're pulling in useful? Because the hard truth is not all data is going to be useful to us. Not all of it has value. But if we have some kind of an artificial intelligence system set up, it can wade through that massive amount of data. It can help you operationalize it. It can help you standardize it, and it can help us determine if this is useful going forward. Another thing with artificial intelligence and machine learning, we saw this with AlphaGo, Google's DeepMind Go player, is that it helps us learn in new ways. So when it defeated the world Go player, it made certain moves that a human would have never made. We never would have thought to play the game this way. And it was confusing to the player at the time, but it turned out to be advantageous, and it ended up winning and defeating that player. But a human thinks in very certain ways, and that's part of our evolution. We're very, we try to be unpredictable, but we're actually kind of predictable in our behavior. That's what helps us get by. We have this schema of decision making. But a machine doesn't necessarily think that same way. It doesn't have that schema that we've developed over, thousands of years of evolution. So it's going to show us ways to do things differently and possibly better that we never would have gotten to had we not built it and sent it through these wargaming exercises. So I think that's a big advantage, that if we can run these with an AI in the background or an AI as an adversary, we can look at, we can gain perspective on, hey, this might be a better way to attack our adversary, or an adversary may do this to us. Now we're prepared for it. They'll also help us identify edge cases. So if we're looking at the very extreme boundary of what could happen or what's possible, that allows us to put some context around it and determine, how did we come to that situation, or how do we avoid it or mitigate it? Or get back to it if it's a desirable outcome. Again, that's part of the AI thinking differently. And it's also going to be the underpinning. So when we have virtual distributed war games like this, there's other emerging tech that we're probably going to be using, whether that's different ways of seeing things through AR and VR, or whether we have a digital assistant with us to mimic something that we might have on the battlefield. We're going to need AI to underpin all of those things. And that leads me to my next point, which might actually be the most important. We can't just buy these products. We can't just buy an AI in a box and set it out to go. We need the people within the organization to understand these things, build these things, modify them, manipulate them, create new ones. That it would be like, buying a jet, which we can do, but not having any pilots in the Air Force to fly them. We need someone who's going to be able to fly these AI things when they're out there. We need those skills in the force. We need to be able to upskill our current force, and we need to be able to recruit and retain those who are coming into the workforce right now who have these skills. And I think that's the most important thing, because the DoD, and again, this is my perspective from the Army, is very rigid for a reason. It's a large organization. Lives are on the line. We do things that way for a certain reason. But if we want to be able to get into this world, we want to be able to do it right, we need to be a little more flexible on the people who are coming in as coders and programmers, either in things like salary and dress code, things that they might be used to in Silicon Valley, but also in the hardware that we use and the networks that we're on. It's hard to ask someone to come join the Army and be a coder and a programmer and then work on the NIPRNet that's severely locked down and doesn't allow outside software and things like that. It's hard to be creative in that sense as well. So that, I think, is going to be huge for the future. We've got to figure out a way to get the right people in here who can give us these artificial intelligence, these machine learning solutions, and be able to retain them and give them a reason to stay with us for the long haul. So I think I still have maybe a minute left, but I think I'm going to end it there. I can give kind of a brief overview to open up the discussion, and I'll hand it off to our next presenter. So thank you.
Thanks, Matt. This is Aaron Dana. Sorry, I'm the moderator. I was stuck in the virtual back room, the virtual green room there for a few minutes. They have let me out. We'll hold all of our questions till the end. So what I'll do is I'll just give a quick thumbnail description of what we're going to do from here on out. So Justin will go next. I will introduce him, and then Paul will go last, and then we'll go to Q&A. Just by way of quick introduction, the first of the complete bios are on the website. Dr. Justin Peachy is a research scientist in the Wargaming program at the Center for Naval Analysis. Justin has designed and directed multiple game projects ranging from logistics to information warfare. He's also worked on projects examining communications technologies and cybersecurity with an effect on naval operations. And he received his PhD in mathematical sciences from Clemson University. And he also worked as a professor before joining CNA. Justin, it's all yours.
Thanks. So like you, Aaron, I had some problems. I'm on my cell phone, so everyone please bear with me if the angle's not quite right for the camera. Aaron, do you have my slides perhaps that you could push?
Yeah, let me, I'm going to try to share screen here.
Sure.
If not, I will get them pushed over to the controller here. We were trying to do this beforehand.
Understood.
And
so I can talk a little bit to them before they show up. So last year, actually, I was one of the 2 leads for a working group at Connections looking at how we represent AI and machine learning and other advanced technologies in our war games. So instead of saying, how does AI affect our war games, we were interested in, if we believe AI is a game changer, and I think everybody does, how do we in the wargaming community represent it in a way that makes sense and in a way that gets us meaningful results? So what I'd like to talk to here in a little bit is I can't claim the work. I can claim that I helped put it all together. But there were 3 themes that really emerged that if we have some slides, I'll fast forward us to them. But there are 3 major themes kind of that we talked about, and I think continue to play a role as we go forward in wargaming for how we represent AI. So the first was to model it in some form. And the challenge with that approach is that, AI are surprising, as was just pointed out. So if I want to represent them in my war games, our solution was, instead of trying to use a machine to play a machine, I don't have a lot of intelligent machines, and I probably won't for quite some time if the AI community is to be believed for general intelligence. So instead, let's use what I have that's plentiful and has a lot of general intelligence, hopefully, and that's other humans. So our approach, as a couple authors kind of explained, was to go through and either use one or multiple humans to actually represent an AI system in our war games. I see you looking perplexed there, Aaron. Do you want me to give you?
No, I think I have it up sharing now.
Okay, I'm not seeing it. Oh, there we go. There we go. So you can, couple slides forward, I think we lay out the three methods that I was detailing. So slide, and I may have a delay because I'm not seeing it update, but there should be a slide that basically says the 3 methods are model, abstract, or ignore, and that's the one.
That's what I have up now.
Okay, it's just my phone's being slow. Okay, so the big 3 approaches. So the first one, and I'm not going to go into a lot of detail, but I can point everyone to the paper that's posted on PAX Sims at the end of this that agglomerates all of these things. So the first one, when we talk about modeling AI, one of our authors did a great job of laying out that, hey, if I've got a single human and I sequester them in preparation for the game, I can treat them very similarly to an artificial intelligence. And there are some other things that we want to do, but you can basically train the human up on your game data set in a way that is useful and gets us close enough to modeling artificial intelligence. There's a second potential approach to model AI, and that's as we step back and we realize that depending on which view you have for AI in the future, it may be a collection of multiple agents. Well, let's use multiple people. And so if you go through the work of having some arguments, and the authors do a great job of describing how you would score those arguments, you could actually, prior to any war game, build out a rough script for your AI with inputs and outputs and the outcomes that you might be interested in. For those types of approaches, the output you're really looking to get out of your war game is, hey, what inputs and outputs do I need? What potential surprising ways might an intelligent agent act that I hadn't thought of? Sometimes, though, that's not really what we want out of our war games and the AI in them, or representation in them, and maybe instead we just want some sort of combat resolution table. So that's where we get into the abstraction. There are some very popular or not so popular, depending on how old you are, commercial games, things like Traveler, that provide mechanics that we would happily steal from to represent our artificial intelligence in the war games. So I don't want to go into too much detail other than to say really what I'm looking for is what are the effects, and how do I don't want to say model, because step one was model the AI with humans, but how do I compare various levels of artificial intelligence and build those out into some combat resolution tables. And the final method, as we look to explore, hey, how might AI affect the future, that was suggested during the working group last year, was that maybe we instead want to actually go ahead and just ignore the AI. And that was heavily shouted down, but I think we should make the argument so that everyone's aware of why we might do that. And the argument there from several participants was, when we play a lot of our war games, we recognize that nuclear weapons are kind of the way we might end the war or move into the next step. But we almost always just ignore them because they don't fit within the objectives for our games. And here the assumption would be that, hey, if every side has AI, I don't really need to look at it in a lot of detail because it's all canceling out. I don't think anyone in the working group agreed with it, but it's something we should consider going forward. So I don't want to take too much more time here. I think I've used about 8 or 9 minutes. So what I'll just say is the paper that kind of outlines all of these approaches is available on PackSims. And right now I can't see Discord because I'm on my cell phone, but if you post something in the Discord chat, I'm more than happy to, after the end of this working group, post that link for people who are interested in learning more about how you might represent AI in war games using these techniques. With that, I'll throw it back over to you, Aaron.
Aaron, you're muted.
Aaron, you're still muted.
Sorry, it looks like the controllers pulled up your slides. I had them, but that's okay. So just by way of quick introduction, Paul Works currently serves as director for the Analytic and Development Group, the Research and Analysis Center TRAC at Fort Leavenworth. He's worked for 34 years as a federal civilian for the Army and the Navy, the last 23 of which he's worked for TRAC, leading major analytic studies, scenario development, and wargaming. And as a fun fact, I have to include this, Paul. He has been gaming for nearly 50 years and is a published game designer with Multiman Publishing, which is only about 40 minutes from my house here in Maryland, where he has done advanced squad leader. I had to squeeze that one in, Paul, being an old timer like yourself. So it's all yours at this point.
All right, thanks. A couple things. I have the benefit of being the going third here. All the people that are listening in, if you haven't gone to the Mad Scientist blog site and the stuff that those guys produce, it's pretty slick. Yeah, right, Matt. Yeah, that stuff, if you're interested in Wargaming the Future or thinking about the future, I would highly encourage you guys just to do a Google and go find them and they've got a lot of slick stuff, and they have compilations of PDF things that are really great too. So anyway, I got those. Second, the stuff that Justin was just talking about, you're going to hear a little bit about what I'm the same topic area, and so let's just go to the next slide, and you'll see the flavor, how it overlaps with that. And so what a lot of where I pull Wargaming the Future for me as part of in my little role at the Research and Analysis Center as kind of the innovation guy, or the guy that kind of is the group that thinks outside the box, is to examine these kinds of questions. And so I do a lot of sci-fi reading, Charles Stross, Ellie Modesset, Gibson, Neil Stevenson, all those guys. You can pull a lot of this what the future is going to be like from them. Now, granted, they're hypothesizing, but it does not seem unreasonable, a lot of their suggested environments. So now we'll get to what I'm going to be speaking about. So track what we do at Track, where we examine the future. There's two big pieces. Every analysis we do, 95% of the analysis we do, is looking at change, primarily organization material and doctrine changes in future areas of operation, future OEs, 10 to 20 years out. We don't, once in a while we go further than that, but primarily it's about, so right now it's 20, 28, 20, 35 kind of time frame. So we're looking at those future OEs. We have the threats, the intelligence community folks come in and provide what they can with that. Looking at those two different, or that future operational environment, we build these operational scenarios, which are the baseline scenarios that the Army community uses for analyses and training and testing. And then we leverage those scenarios and then look at those hypothesized changes in those environments. So, for example, if we're buying a new ground vehicle, and there's various potential options that have a range of capabilities, we'll comparatively examine those in these analyses. So in that case, and that's our main production efforts that Track does. We produce the scenarios and the studies. In my role, I try to find or get hints of, sniff out hints of, so to speak, future areas where Track is not looking at stuff, but where I think we're going to need to think about at least having some background on that topic area, so that when we do get asked a question about it, we're prepared for it. And so my group produces white papers, and then we produce reports as part of what we call these methods and models analysis working groups, these MOGs. And the MOG process you can see over on the right-hand side of the slide. It's very similar if you know what a capability-based assessment is within the Army and the Defense Acquisition System, but you identify what representational requirements. So, for example, let's just use cyber, since that aligns with what we're talking about here. We get together, and it depends on how fast we want to turn around on this, but typically for the cyber MOG that we did, it spent about 6 months gathering SMEs together, doing a lot of lit research, and identifying what kind of representational requirements we need to have in our methods, models, and tools, our analyses, to effectively represent that topic area. Then we vet what we can do right now against those identified requirements. And inevitably, we identify gaps. And we characterize those gaps as knowledge gaps, just thing that we need to know more about, data gaps, that we can do it, but we just need data to represent it in our SIMs or in our analysis, or algorithm gaps, and that means we have to change a SIM or whatever we need to do. And so those are characterized as KDA. That's the knowledge data algorithm acronym. And then we identify mitigations. So we say, okay, what to mitigate this gap, what do we need to be able to do? And then we do have different levels of mitigation to say, okay, here's a low-hanging fruit mitigation and so on, or more involved in the time-consuming one. And then there's a precedence. So if you say, well, there's a very high priority gap that's at the top, but you can't fix that one until you fix gap number 7, because it just doesn't make sense. There's like I use the analogy of like significant digit problem. You can't fix one without fixing the other. Otherwise, you have two different levels of resolution and it doesn't work. Anyway, so that's the MOG process. And so here's the bottom bullet here lists all the most recent research efforts we've done. We did a robotics one, which was about autonomy, very much aligned with what we're talking about at AI here. We did a regular warfare analysis, how to represent that. And you can see, I'm not going to read all of them. But one of the things that came out of a lot of these is this, how we represent cognitive behaviors in the entities in our models and simulations. And so on the next slide, if you go there, we'll talk about that. So this was a common theme across quite a number of these research efforts we did. And that is that our entities in our simulations, which were designed to represent combat operations generally, they're not sophisticated enough. Those decision entities, whatever they are, whether they represent a fire direction officer or a commander in a company or whatever that is, those little virtual nodes are not sophisticated enough to distinguish between different levels of AI or autonomy or even mission command, to be perfectly honest. And so kind of aligned with what Justin was talking about earlier, we conceptualize these entities kind of as a systems dynamic node, a model node. And you can see the node in the middle there that has, you can't see it, but it's how the data fusion and decision-making process, kind of a super OODA loop in there. And coming into that node are previous decisions that have been made and stuff that's going on, immediately going on, like the entities involved in. And then from the top are like the environment, the surrounding state conditions and memories that node has retained. And then out of there, then it makes a decision, whatever that entity is, it makes a decision, then it pumps out a decision or action it does. And then there's a data capture that really doesn't go on to a different part of the model or the flow of the method or tool you're using, but it's just something you capture to say, okay, we figured out why this entity made that decision. Okay, well, it sounds very reasonable, but in a simulation, that to make the simulations run as fast as possible, these ins and outs arrows are very small number. And the decision-making stuff that's going on inside that node are very rudimentary in most cases. So what we identified is okay, even if you soup up the way it's making its decisions inside that node, it needs to have information that we're not providing that entity. It just doesn't have that information because the sim's not giving it. And so right now our sims can't do this. So we have these big combat model simulations that we use to track, and we have identified a number of different mitigation upgrades that need to happen on this. But until that happens, and oh, by the way, typically in my office, we do these white papers and MOG reports, and those things sit around until track gets asked a question that has to do with the topic area. And that forcing function then forces us to get to work on it, which is, that's just the normal way things work. And so, but it's useful to have this jump start work we've done. Okay, so then how do we deal with this right now if our sims can't work? Well, we have to use war games. And war games, that the way we use war games, they're the perfect way to model these what we call structurally indeterminate situations, these problems where you don't know the full implications of what's going on, and you don't know, you can't understand all the different nuances and second, third order effects and so on. And so that's what war games are perfect for. And for us at Track, we have a recognition that we have models and sims, these combat models. Well, they're not war games. Those are useful if you know all the state conditions and stuff, and you can run them 1,000 times and get big piles of statistical data. But war games are what we use to help feed those models when we don't know how soldiers will use something or the implications of a technology. And we use these war games to flesh that out, and then if needed, we use the results of those to feed the more hardcore closed loop models. And so for me, it's It's we take all these ideas, we identify problem areas, and in this case for AI, it's all about, and I like what we talked about earlier. It's all about building out that knowledge of what the functionality of AI is, so that we can, the players, when we do a war game, a focused war game, we can get some nuances that then we can use to leverage and build a narrative out of that war game. So that's how we, that's what we do at Track. And I guess now I'll pass it back over to Aaron.
All right, thanks, Paul. We did have one question came in while Dr. Peachy was talking, and it says, any thoughts on Miss Kate Crawford saying AI is neither artificial nor intelligent in her book Atlas of AI? Any comments there?
Sure. So I actually have not read Atlas of AI. I've read a ton of other AI books. So when I write about stuff like this, I try to avoid the term artificial intelligence, and I will say machine intelligence. Now that still is smuggling in the assumption that it's intelligent, and I have two alibis for that. The first is that I'm trying to avoid, if anyone's familiar with the arguments from philosophy on strong AI versus weak AI, the official thought experiment is the Chinese room experiment. I don't care if it's intelligent in the way I define intelligent or not. It's an agent that is taking inputs. It is providing outputs based on some decision rule that's either explicit or implicit. And that's really what I care about. Next thing you know, we'll be debating, are we as humans all P zombies? And I don't want to go down that route. So instead, my response is that really what I have is I have a machine agent, and quibbling over and fighting over whether it's intelligent or not doesn't buy me what I care about in my war games. What I care about are the inputs, outputs, and the effects that has on the war. That doesn't mean someone shouldn't be thinking hard about whether these are artificial or intelligent. That's just not something I'm necessarily interested in doing. Over.
Okay, anybody else want to add into that?
I think Justin hit it on the head.
Basically what you can do on a cell phone when the pressure's on. All right. So I have one that I wanted to ask, having worked in the threat realm most of my career. Looking at this from a threat perspective, should we be concerned about the US's ability to either properly mimic what any kind of adversary AI is doing, or properly be able to game an adversary's AI, depending on how their AI works? I mean, we've already seen, I think it was in this past week, the Chinese talking about using AI with their pilots, much like we've had news articles in the press about our pilots trying to fight against AI, gaming against AI. Is that something we should be concerned about and putting effort towards? Over.
I'll start with this one. Yeah, I absolutely believe we should. We've done a number of kind of focused war games on multi-domain operations, looking at 2035, and this stuff is coming, and it would be, and also look at where we as the U.S. have AI. We're leveraging AI, whether it's just a way to filter information to a soldier on a visor, or if it's making some kind of actual tactical decision. But we got to look at how the threat's doing it, because what we want to do is we want to manipulate that or take advantage of it or whatever, and we want to do it, examine our own, so they can't do it to us. So yes, I absolutely believe we should be doing that. Over.
Anybody else want to add in, Matt or Justin?
I'll just jump in real quick. I mean, I think what Paul said makes sense. I'm not sure if I understand the question correctly, because when I read it originally, to me that sounds like an inclusive or. The answer is yes. We should do those things. They're not mutually exclusive, but maybe not mimic in this. Go back to what Paul said. We have to understand what the adversary is doing and how well they're doing it, and we need to be able to determine if there's a gap there from our side to theirs. And we need to be able to beat it. If so, we need to be able to be working on our own things to to not just rise up to the level of the adversary, but surpass it and be able to handily defeat it. So in order to do those, you kind of have to be on both sides of it. We need to know what they're doing, and we need to know what we're doing. So that's kind of my 2 cents on it.
Yeah, Justin, and you want to add anything?
No, I think they covered it both pretty well. Yeah, we should be concerned.
Yeah, of course, my point of view on this is from the issue of warning, right? We don't want 5 or 10 years from now, we don't want to be surprised and find out our adversaries are either ahead of us or their AI is doing something that we didn't anticipate. And we've been gaming against one version of their AI, which didn't really mimic what they did. And I know this is a difficult topic to talk about in this area, on this network. So we'll just leave it at that. All right.
Well, let me piggyback on that just real quick.
Sure.
So,
oh yeah, go right ahead.
Somebody gave this statement at a Connections a number of years ago, and it's always hung in my mind, and it's applicable here. And that is the West is typically playing chess. When we think about this quick, okay, we got to make a decision about something that's a direct fight, head-on-head battle, and the Eastern guys are playing Go. They're doing stuff that they think that they're going to come to fruition a generation later, and we don't think that way, not very often. And so this is one of those cases where it might be useful to apply that thought process over.
Okay, great. Thank you. Any other comments on threat AI?
Well, I think that's why situations like this are so important. These types of conferences, these types of explorations, where we are looking at the future. Don't expect something to happen tomorrow because we had this conference, but this conversation, this discussion gets in people's minds and filters up to senior leaders who, had it not been for events like this, wouldn't be thinking on this road, or wouldn't be thinking about these topics. And now maybe something that would have taken 15 years gets done in 5 years. So I think it is incredibly important to be thinking about the future, thinking about things like this. So just to Paul's point there.
Right, thanks. Quick comment, and then we'll go to the next kind of question. There was a response to the answer from Justin. Thanks for the response. I'm reminded of the book The Feeling of Power by Isaac Asimov. So I'm not familiar with that book, but maybe one of you is. I'll be looking it up when this is over, so that's great. Next kind of question, it says, one of the people watching said, my concern is that the government or military expenditures, I assume they mean U.S. government or military expenditures, will never equal the money going into this area, I assume they mean AI, by organized crime. I hadn't thought about organized crime, but certainly if there's an area that's non-military, I would think organized crime would have the resources to do that. Anybody want to comment on that?
Oh yeah, a lot of the books that I mentioned, or authors that I mentioned, that's the main flavor. Yeah, absolutely. The organized. I'm reminded of several different instances in there, and Charles Strauss and those guys, and it's and Gibson. That's the fight. The bad guys are leveraging this technology to make money, however they're doing it. And in cyber world, it's they may not be selling drugs or weapons; they may be selling information or something like that. It's very very interesting. Over.
Yeah, you think about just as basic now as Social Security or people's identification cards get stolen, their personal information, the value of that, and that's just the start of all this. Anybody else wanted to comment on that at all?
Yeah, so I'd be interested in seeing the numbers behind that, because while certainly I agree that this type of technology has become democratized, I mean, you don't have to be part of a big lab or a big company to build artificial intelligence or work on it, anything like that. And I apologize for using artificial intelligence, the term. I know we went and knocked that out earlier, but for simplicity, I'll stick with it. The access is there now. I'd be interested to see if organized crime groups can match governments or nation states in terms of spending, though. Now, that doesn't necessarily mean they won't be effective. You don't have to spend that type of money, but that'd be something I'd be interested in looking into. Now, certainly an organized crime group could have better focus and shorter timelines for certain things, because when you delay things in the government, it's ho-hum. When you delay things in organized crime, there may be serious consequences. So I'd be interested in seeing the outcomes of that. But I'd be interested in looking at the raw numbers on investments into that. Over.
And certainly, organized crime doesn't have the restrictions that governments may have, and may not necessarily have all the bureaucracy and the overhead that governments have to deal with as far as those restrictions. And the comment was the Feeling of Power is actually a short story by Isaac Asimov, and apparently it's online, so I've got some reading for tonight to do. So thanks for that follow-up. Another kind of follow-up question, following up on the adversary AI capability, would you often or always do red teaming for your AI red team? I assume they mean you get together and work it through as far as what you believe the adversary is doing based on information that you have available to you.
I'll start, I guess, with an answer there. I think my answer is a qualified yes, not having thought about this, extensively. But there are a couple things I think I'd want to, or there's one pitfall I'd want to avoid with the red teaming, and that's groupthink. And so you need to be careful how you red team your red team AI players, because you don't want to close down some sort of very creative approach because we have groupthink and DoD or the broader AI safety community or whatever all thinks a certain way. On the other hand, there is some value in my mind in doing some of that, simply because I want to be, and we can't talk about it right on this line, but I want to be informed by reality. So I don't want to say I want to be realistic. I want to be plausible. And so there's the fine line, and whether red teaming your red AI team is the right way to go about it, I'm not sure. But my initial response is, yeah, that's a qualified yes, but I'd like to dig in a little more, kind of why we would be doing that. And I'd like to avoid the groupthink or the completely unfounded in reality challenges that I think we're trying to balance there. Over.
Yeah, thanks. I mean, if you look at, U.S. threat assessment historically, we have this tendency to, underestimate, then sometimes overestimate, 9/11 being a great example. We underestimated the threat and then kind of overestimated it for a few years. So trying to get it just right is always a calibration process, and your information is imperfect, so the fog piece certainly weighs in on that. And it really kind of gets to our next question. Anybody else want to comment on that?
Yeah, I had one to follow up on that. One of the things it's been on my mind for the past year or so is what I would like to do is bring in a group of our newest interns that have very little military background experience, and they'll have multiple degrees. Some will have English degrees or whatever. I mean, they have to have some math to get into track, but they'll have a wide, broad experience. And I'd like to give them the assets that we have in the blue assets that we have in a scenario, and fight the red. Don't tell them anything about how the fight's supposed to progress. Tell them, say, hey, you guys go defeat those bad guys, and see what they come up with. Don't give them the MDO doctrine or whatever. Just say, hey, here you go. And to avoid that groupthink thing, because anyway, it seems like we're just, in some ways, when we're doing studies now, unless we break out of that, we're not shifting the paradigm in how we fight. We're just fighting the same kind of way with adding cyber in or something. No, let's see if we can jump ahead. Anyway, over. I'm going to do it someday soon.
One way to avoid mirror imaging is doing that kind of out of the box thinking and bringing in new brains that haven't been polluted yet with all of our biases and previous experiences is a great way to do that. We try to do that in the intelligence business as well. I'm sure you're aware. Any other comments on that topic before we go to we have another question?
Just to champion what Paul said. I love that line of thinking. I love that thought process. If you want to break the system, bring in people who don't know what the rules are and let them go.
Great point. Let's see. So a new question, and this one they should be posting up in the window here in a second. It's a little bit longer. Ask for thoughts on this statement. That even not knowing the future of AI in 20 years, right? Because it's very hard to look out 2 to 3 years, never mind 20. We attempt to game it now so we can at least have the processes in place when the future picture gains greater resolution. In other words, there's still some sort of benefit even though we don't know. The U.S. intelligence community every 4 to 5 years releases its global trends document, unclassified, that tries to look out 15 to 20 years. And if you go back and look at previous ones, they don't always get it right, but at least they make the effort and force the thought process. I think this is kind of like that same thought. Your thoughts on it?
Just a few cliches jump to mind when we hear this. One of the quotes we like to work off of is, point prediction is a sucker's game. We're not gonna predict the future. We're not gonna know the future. We can forecast out a range of possible futures, and that will help us vector in. But the other cliche we'd like to go to is we're never going to be right about the future. We just need to be less wrong than the adversary. And so this statement is kind of what that gets to. Humans like to think very discreetly. It's either yes or no. It's black or white. We either solved the problem or we didn't. But when you're looking out 20 years in the future, you're not ever going to solve the problem and say, okay, we did this war game. We got the answer. We're done. What we're doing is just trying to explore. We're trying to gain any amount of information that will help us, and then we can go back and refine as we get that information, and the next time we do it, it will be better, and the closer we get to that endpoint, it will be clearer. So there's great value in doing this, because you can't start 20 years from now and say, okay, AI is a thing, let's start getting into it, because you've missed those 2 decades of information and knowledge. Over.
Yeah, that's good. There's a diagram that I saw that a few years ago, that the human social cultural behavior, some project they were doing, it was like a cone, and the end of the cone, the narrow part of the cone, is current day, and then it expands out, and they say, okay, well, we want to be able to get a 2 sigma, a 70-80% idea that of where the edges of that cone, that we're going to be somewhere in there, but we don't know where we are in there, or where we're going to be in 20 years. Now that's confounded by the fact that, okay, well, there's another prediction, another couple of cones that are down there that overlap. So you may have something that flips over because of the 2 technologies or something may shift it a little bit, but at least you are looking out there to get at least some idea. Over.
Anybody else? That is our last question that I have up here. We're done. We have 10 minutes left. I didn't know if anybody wanted to make some kind of closing remarks pending any other questions coming in. Oh, and by the way, I did post in the on Discord the link to the Global Trends 2040, which is the most recent version that just came out in March, of the National Intelligence Council's best guess of future trends, and everybody can take a look at that. It's unclassified, so it's great. Closing remarks by anyone?
Since we've got the time, I'll just continue and augment what Paul was saying about how great Mad Scientist is, and I'll use this as a time to make a pitch to solicit folks to, quote unquote, join the team. Almost all of what we do, I would say 95% of what we do, is completely open source, and we interact with the public and think tanks and research institutions all the time. So I'll take this moment to appeal to everyone to say, if you've got an idea that you think can help the Army, and maybe you have no outlet to put that idea out there, we would love to have you come write for us. We have a blog. If you just Google Army MadSci, you'll find it, or it's specifically at madsciblog.tradoc.army.mil. And we've also got a podcast that we do that comes out every 2 weeks. And most recently, the one that I want to get you guys listening to is our sci-fi series. So we've reached out to sci-fi authors, people who are writers and creators who are thinking about things differently than we are, and who are communicating it in a narrative style. So we've got 4 really, but 3 episodes. The first one's with Ronald D. Moore. He was the writer of Star Trek, Next Generation. He did the reimagining of Battlestar Galactica, Outlander, a ton of stuff. I mean, a legend in sci-fi production. We also talked with Pete Singer and August Cole, who have the book Ghost Fleet and most recently a book called Burnin'. We talked to them about fictional intelligence. And we just, our podcast that drops on this Thursday is with Dr. Malka Older, who has the Sentinel series. She has books called like Infomocracy, looking at how technology is going to affect the future. So please get involved with us. We'd love to hear from you. We'd love to feature you if you write anything. That's my little pitch.
Well, it's great. That's actually very good, because that leads into, we did get a question here, and we've got 6 minutes left. It says, how can we train AI to predict black swans when we, by definition, can't predict them ourselves? This is a classic problem when trying to do straight line predictions. You know, what's that disruptive event going to be that you just can't possibly imagine? Is there something we can do along these lines using AI?
So I think it's an interesting question. I think falling back on the math behind AI playing games, it would be great if we could have a computer explore the entire world tree instead of the game tree, if you're familiar. You know, hey, I do a Monte Carlo tree search for the entire state of the world. And then we suddenly realize we're asking a computer or a machine or a collection of machines to basically simulate the world itself. And without getting into quantum computing and whether that makes it possible, that's probably a bridge too far. But so that's the technical side. Stepping back and saying, how do we train AI to predict black swans when we can't predict them ourselves? I think I've been asked a similar question from some military sponsors, and my general response to that is that if I could predict them, sir, they wouldn't be black swans by definition. So great. You know, how can I train an AI to do it? Yeah, have it basically be able to simulate the entire universe and tell me the interesting edge cases. Short of that, it's a fool's errand, because we don't predict black swans by their very definition. Over.
So I totally agree with what Justin just said. For me, this is a perfect place where wargaming shows its mettle. It's like if you ever played war games, and like I said, like Aaron said, I've been playing them a long time. You roll dice, right? And you cannot predict the series of outcomes of 150 die rolls in a game. You just can't predict that. I mean, or you could, but it takes such a huge computer, like Justin was just talking about. And so you have to be, war games force you to be prepared flexible for things that will emerge. You don't know are going to happen. And so they force the participants to think about that. And so a good example from sci-fi authors is the Ender's Game thing. That they didn't use a big AI. They may have used a big AI to help them identify the kids that they were going to put in the program, but they had kids. They had these kids that they trained that they were using to actually do this stuff. So anyway, over.
I had an answer lined up, and Justin said pretty much exactly what I was going to say. Definitionally, you can, otherwise it's not a black swan, right? But so I think if we're tugging at strings here, the best thing you can do is maybe identify low probability, high impact events, and then a mitigation strategy, and hope that your mitigation strategy for those helps you when this inevitable black swan event happens. I think that's probably your best bet. So you can at least do some exploration in those realms and come up with some strategies and some defenses, and then, cross your fingers and hope that those things translate to what's actually happened.
Well, Nassim Taleb thanks you, because it allows his book to still be relevant. It hasn't. You can still have it on your bookshelf. It doesn't have to be relegated to used bookstores yet. His book, Black Swans, of course. Any other closing comments in our final couple of minutes here? If not, we'll give everybody a couple minutes of their day back, and I'll go prepare for my next panel.
Thank you so much, guys, all for pulling me into this. Appreciate it.
All right, thanks. And thank you, everyone out there, for tuning in. And for those of you who will tune in this evening because you're at work today and like me missed a lot of yesterday, but now I'm going to start watching it at night. So thanks, gentlemen. Thank you for your patience with the rocky start. So we will see you all on another panel at some point. Thank you.